Good afternoon. I'm Emily. This is Siggy. We are two engineers on the Dart team at Google. And today we'd like to talk about some of the features in Dart that help make your web app development experience more pleasant and productive. So this is not, okay, thank you. This is my impression of web development today. It's thriving, doing well, but things are maybe evolving rather than being designed. And as a result, a lot of APIs are the way they are for historical reasons rather than making the most sense for the developer or being the most readable. Additionally, the way the web handles errors is they handle them silently. And this can be great for prototyping when you're trying to get your app up and running to begin with, but when you have larger applications, it becomes frustrating when you're trying to pinpoint the source of your error.
Now, the web also has a great foundation layer at the bottom that you can use to build the richer things. But when you're building large applications, you start getting into structured applications, thinking about models, views, controllers. And to cope with all these needs, people have created frameworks. There are actually many frameworks out there, and they don't necessarily work well together when you want to actually use a feature or a widget from one framework into an app that uses another framework. So what we're doing with Dart is we're taking a new Great. So what we're doing with Dart is taking a new look at this problem and giving you a pleasant feel. So what we want you is to have now an experience that you actually can feel productive with it. So we've taken all these APIs that have grown organically, and we revisit them and do a design of the HTML library so that now it all looks uniform and something that you can discover easily. We're also taking advantage of a lot of the features that we have in the Dart language. Some of the things help in making things discoverable, but it also helps that in Dart, you can have a lot of things that give you warnings ahead of time. We have the notion of optional types and things that can let you know if you're doing something wrong, but if you still want to get going and ignore the warnings, you can do it and continue your productivity in the typical prototype mode.
And as Siggy mentioned, there are a lot of frameworks that are being developed to help you organize your models and your views, but they don't necessarily work together. And currently, they're developing some web standards to help you do this on your own. And Dart is keeping pace with these standards and integrating them into their libraries and in the language so that you can use all these features on any browser that you want today. So we'll take a quick look at how some of the design of the Dart language and Dart libraries have influenced the HTML library in making your web app experience. So let's take a little example. Let's say you have a collection of nodes from your HTML nodes, and you want to loop through them. What might seem like the common way or what you would think to be the default way to do this would possibly trip you up in JavaScript. So if you do a simple little for each loop, you're not going to get each node because you have this array-like object you're looping through. You get your indexes, and then you also get the links and some other things. In Dart, we return native Dart lists. So yes, you can have a pony. So everything behaves just like a Dart list natively in the language, and so you can loop through your nodes as you would expect. And so native lists are not the only thing we're returning from the HTML library. We've also adopted a lot of other Dart types, for example, futures and streams, and are returning them as well. So as an example, the idea behind a future is just like a callback, but the difference is that this is your function call, and if you had a callback, you'd be putting it right here. With future, you return the future that when the value completes, you do your callback. And the great thing about futures is they are easier to compose. And so if you have a sequence of events that need to run, then you can easily have them change. So we have then and do something else, as opposed to callbacks where you might have sort of spaghetti callbacks going from here to here and so on.
So you probably, if you went to the earlier talk today on on Dart and what's new in Dart. You probably saw some more examples on futures. Just briefly, another thing that Emily was saying about composition, like you can see here I have this catch error. This is a way of now handling both normal control flow and exceptional control flow with futures. Another way in which composition is actually helpful with futures is that you can run multiple asynchronous operations together. They can run in parallel, and they can create another future that waits for the individual future to complete. So when we're looking at the HTML library, we know that there's a lot of things that are asynchronous by nature, and what we want to do is to take advantage of these types and use them in this library. Now, one clear example of that is the use of a network request. When you want to do a network request, you create an object in JavaScript, for example. You set it up by setting a callback so that you know when the answer is actually available, and so on. In Dart, we can actually now just get a future back, and then now you have all the existing libraries available to you that are functioning on normal futures. You can also use them with this particular future. And in the same way that we have futures, there's the notion of streams, which is like a repeated version of a future, and we use that a lot in events and when listening from events from the UI.
So Dart also has libraries, and we use this to our advantage in splitting up your huge HTML namespace. So we have sub-libraries, for example. All the things that are related to WebGL are in their own space. And also, this can also, in addition to semantically grouping these things together, this saves you some typing. So for example, we have all the SVG elements and all the SVG types in its own library. So you don't have to type SVG element. You can just say rect element, and so on with HTML elements and others. Dart also has named arguments, and we use this to our advantage in helping making the APIs more pleasant to work with. So here's an example we have. We're programmatically initializing a mouse event in JavaScript, or one way to do it. And because it has a whole bunch of optional arguments, but they're positional. And so if we wanted to specify one non-default value, this meta key value, then we have to put all of the other default values in between. And when you look back at this later, it's a little hard to read and understand what was the programmer intending when they wrote this line. So with named arguments, all you have to do is put the ones that are not your default values. And so it's much more clear what the programmer's intent was. Named arguments also are helpful for discoverability. One other way that the DOM APIs deal with named arguments is they take a dictionary and you can have collections, or you put in keys to specify the behavior for these functions. This works, but it's not so discoverable. So you have to look up what magic keys do I need to insert in my dictionary to make this call. In Dart, we've expanded a lot of these dictionaries into named arguments so that when you're typing, the Dart editor will autocomplete and show you that I have these optional arguments that I could also include.
Now, name arguments are one great way in which we can improve discoverability, and there are many other things in the Dart language that also help. The fact that we actually have types, and we can actually exploit this in many ways. For example, when we are talking about CSS and doing CSS manipulations, the very common way to do that today in JavaScript is to do strings and concatenate strings and put them together. Now here we can actually have a specific type for talking about the style, for talking about the property of the background color of this particular style object, and so on. Now, what we're going to do next is Emily's going to actually show you a little demo in our editor and demonstrate a little bit of how these things work.
So, as a matter of fact, this whole presentation we're working on is actually, or that we're presenting, is it's a web page. It's a web app. And it is written in Dart. And so our demo will be adding on some functionality to our presentation. So, in the presentation mode, let's say I have this div here and I want to draw your attention to it. So I might want a yellow box to grow when I mouse over it. So how do we do that? Well, we flip over to our Dart editor. And this div's ID is discoverable, so we'll look it up. So first we query. And then we want to see what events are available for this div. So we say on, and autocomplete helps us. We want a mouse event, so on mouse, and we'll do over. Now mouse over produces a stream of repeated events when this happens, so we want to listen to those events. And And when this happens, we want to call toggle style to, I've already added this CSS style to add this little bring your attention to the box. So we save and refresh. Now, when I mouse over this div, we got a nice little yellow glow. Also, jQuery is a super popular framework for developing your web apps. And for a couple different reasons. It helps with working with CSS transitions and modifications. And it also helps eliminate some cross-browser differences. And Dart, we provide these things in the language itself, so you don't have to import any extra libraries, and we worry about all this for you. So as an example, let's take a look at CSS manipulation. At the very top, we have how you would add a class to in plain old JavaScript. And as I mentioned, this presentation is in Dart, so we're querying all our slides, and we're adding this swing class to the elements. In jQuery, it's much more concise. You just query all your slides, and you call add class. In Dart, we have the same idea. We have a collection of your classes is a collection of the classes that are applied to the element, and we add swing to them. So as a demo of how this works, since this is a presentation written in HTML, and you think, well, great, I would love to write all of my other presentations in HTML. I really would like to switch and use the web for all these things that I develop. But in my favorite presentation software, there's this great animation effect that really is important to drive the point home, and I can't switch to HTML. Never fear, we have ridiculous slide transitions as well. So with this little button, I'm adding this swing class, and we have absurd slide transitions. All right. Additionally, Dart works, JavaScript has, and jQuery works on improving your, eliminating some cross-browser differences. So an example, we have WebRTC, which is the real-time communication protocol for video chat and such. And a lot of browsers have implemented this, but they are behind various prefixes. So you have Mozilla, WebKit, and so on. And so if you wanted to use this in JavaScript, you needed to determine which of these was defined and then call it. In Dart, we deal with all of this for you. So all you need to call is get user media, and we determine which browser you're on, and so on. And the same is for CSS selectors as well. So as a little example, we have our WebRTC demo. And okay, so this is Chrome, small potatoes. Let's switch over to another browser, and I will prove that it works here as well. Yes. All right. Oh, let's stop that. jQuery has also popularized the idea of chaining. How this works is we have a snippet of jQuery, not how you would actually write it in real life. But what we're doing is we're applying a bunch of different styles to this Cascades demo class, or Cascades element. And so we're calling element.css repeatedly to apply all these different classes. jQuery has often in many of its APIs will return the original calling object, so it will return this element, so that then you can chain your calls. You can say element.css, textshadow.css font family, and so on, so that you don't have to repeat yourself as much. In Dart, we have the same thing in the form of method cascades. And the great thing with method cascades is they work on any function in Dart. So you don't have to rely on the API designer to write it that way for you. You can use it on any function you want. So this also works on functions and as well as setters. So in this example, we're using we're setting a bunch of different styles using this double dot notation to set some styles. And so as a demo, we are setting the style of our web page, our HTML presentation, and what better style to set than 90s retro web page. All right, we'll go back to the future.
Cool. So we've seen great things that we've done so far improving that base layer. How do you actually interact with HTML? The next thing we're going to look at is what happens at a higher level. How do you build large web applications? Now, I don't know about you, but sometimes I'm curious about a very awesome feature I see on a web page. And I open up the web inspector and I see something like this. Right? This is actually my Gmail inbox, and it's obviously not very readable. In fact, there you I think that's actually part of like each one of those divs can actually represent one of my emails or like threads on the inbox. But what this highlights is that we're actually using something else to build this app. It's very unlikely that people wrote the code this way. What we have is that people use frameworks, and these frameworks actually generate or transform the code and minimize things in a way that then would generate that. Now, if you use a different framework, most likely it's going to minimize it in a different way, and they're not going to be compatible with each other. So this is a general problem on the web, and many people out there had been thinking about this and thinking how to make these things better, and it's actually very exciting times because there's been now a lot of proposals and new standards being proposed to add a lot of features to the browser itself. And the idea is that all of the things that are done by these frameworks can be supported directly in the browser. And that way they can actually interoperate more easily. So you might have actually seen a lot of this content earlier in Google I/O in different talks, like different web components talks and so on. But I'm going to dive a little bit more into this in the perspective of Dart. Now, what are all the standards about? There are mainly like 2 points I want to highlight. One is, how do you actually save time and be more productive writing code so you don't write glue code, stuff that is just always the same. And a typical example of that is binding your UI and the part of the view with your data model. And it's very common that you want to actually do that automatically. The other part is, how do you actually encapsulate what you're writing and make it reusable so you can actually work with a lot of people and you can share your code with others. And this is where things like web components, custom elements, shadow DOM, and all these things come in. So in Dart, we have this project called Web UI where we are keeping pace with what all the standards are doing and implementing them for you in Dart. So you can start experimenting, giving us feedback, so we can actually give feedback given to the entire community.
And use them on any browser. That's right.
So what we're going to do next is dive a little bit in more detail in some of these features. So the first one I want to talk about is observability. In JavaScript MXScript 7, there's a proposal that's been accepted to add the notion of observing data changes. So the idea is that you can create an object, and then you can call something like object.observe. And then after that point, anytime you mutate that object, you add a property, you change the value of the property, you will get notified in a callback. So something very similar is that we're going to be we're actually supporting in Dart. The way we declare this is slightly different, just in the way that the languages are just slightly different. In our case, we use an annotation, say the add observable, and we're going to make that class in some way observable. So once you have this, there's actually a great power in your hands. You can start writing programs in a more reactive way. You can listen to changes that come from data from the network and react to that in your own way. But it's especially handy when you want to glue this code into your UI and create now data bindings that are automatic.
So as an example of this, we have a little counter here. And this is useful in the context of our presentation if we're watching time, that this is counting since we've refreshed the page. How do we implement this? Well, let's take a look at the Dart code. We have a counter class. And the interesting part is this down here. Our timer is every second incrementing our counter. OK, so that's fine. But what does it look like? How do we notify the web page to update and redraw? That's it. We put in this little double mustache syntax. And this tells us that we want to bind the values. When value is incremented, we want to update the web page. And we, underneath the scenes, take care of all the boilerplate of when to update the view and listening and so on, so you don't have to worry about this.
So now the syntax that you see here might be actually slightly different than what you've seen in other presentations because everything is actually changing under our feet and we're just keeping pace with that. So this is actually likely going to change in just a couple of days. In fact, it'll be slightly different. So what we just showed here is an example of one direction of bindings. You have something changing in your data model and you want to reflect that in the UI. Another thing that you might want to do is go the other way. You can actually then have an input box and any change that you make in the input box be reflected in your data model. So here I have a little example where on the first line we have something that is similar to what we had before. I have a model where I'm going to actually read the value and put it in my UI. And on the second line I have the input box and the special attribute bind value does the other direction of the binding. Now here's the same code running. And whenever I type something here with typos, you see them reflected immediately on the other part of the UI. So what's going on here is actually when you actually look at the Dart code associated with this is again very simple. It's just an observable object and that's all I had to write. Now, bindings are very useful for these simple examples, but they actually scale to make it possible to write more sophisticated things as well. Given that we're doing this presentation in Dart, here's another interesting thing that we could do. Say I want to have an index of all my slides. So what I'm showing here is a little list of all the slide titles that we have in this presentation. And I can even search for them, and I can say future. I can actually click on one of those slides. It jumps back to the slide number, and I can come back. Now, this is all written using a lot of these bindings and features that are becoming available in things like model-driven views. So here's what that code looks like. What we have in the first two lines is similar to what you saw before. Is an input box where we're binding the value of the query. So every time you type something in the search box, that's now bound into this particular variable. Then we have this other variable, matching titles, that is selecting those things that essentially match that particular query. And we're using that inside of a template to do this kind of iteration process. We're saying that for every title that matches, we're actually creating a list item in our UI. And here's essentially where we're actually putting the text of the title in our slide. And finally, we have this extra attribute here to hook up our event listening. So anytime we click on it, we will jump into a particular slide. Now, this is actually something that looks similar to how normal HTML allowed you to put like event handlers in JavaScript. But there's a difference here, is that we're actually transforming this and generating code in a way that it would actually be efficient by default. It's actually doing the code that you would normally write if you want to make it efficient by hand, like finding the element and attaching the event listener programmatically. And it's also made in a way that is secure by default. And I want to spend a couple more seconds talking about security in general. So in the Dart team, we care a lot about how do we actually make creating web applications easier. And one thing that people stumble a lot is on how do you protect your application from things like cross-site scripting attacks. When you're using things like templating, a lot of these things can actually be prevented more easily. In particular, when you see this binding here, we know that I'm injecting some content in the middle of that HTML. But because I know where I am, I know for once that, okay, this is just I'm putting text here. There's no way I can actually put something like a script tag. I know that I'm injecting it that way when actually running this code. And there are many other things like that that you can do. So even in our Dart HTML libraries, we're currently looking into how we make something like inner HTML safer and have either validation or checks or things that you can do. And if you're using templating, reduce the cost as much as possible so you don't see any overhead at runtime. Cool. So now that we have these views and we know we can create something really pretty, the next thing we want to do is make it reusable. So this is where custom elements and shadow DOM and all these things come along. So here in the bottom, there's a little bit of the sample syntax, and you might have seen this earlier today. Basically, the idea is that I can define a view and wrap it in with a name, and I'm going to use this name as a tag in my HTML. So here I'm saying the name of my tag is something like my element, and later on I can use that tag in my HTML in the bottom saying my element foo.
And the way I like to think about this is object-oriented programming for HTML. So here we're simply declaring our custom element or class, and then we're instantiating it. And they can have varying behavior depending on each element that you instantiate.
Exactly. So one thing that I can highlight related to that is that custom elements allowed you to also override or extend the behavior of other elements that exist in the DOM. And in this example, we have here this extend div. And when I see that, then we know that actually this is going to behave like a blocked element, not like a span element, for example. And when you instantiate an element, there's an alternative syntax that is based on the fact that it knows that, okay, there's some base element that we know out there, and I can say, well, this particular div is an instance of my element, which is the subkind of div. So I want to switch to the editor and show you a more realistic example. And what we're going to do is open one slide here. This slide, in fact, is a custom element itself. And what I have here on the top is a commented out custom element. I'm just going to clean this up and go through the code little by little so that we can actually see what it's doing. Basically, I'm interested in adding a slide number to my presentation. I just want to know what slide that I'm on right now. So I'm going to add a custom element called my slide number. It's going to be essentially a div, and I'm going to associate with that element a little bit of Dart code. So here in this attribute where I say constructor equals slide number, I'm saying that this is a class in Dart that I want to associate with my element. Now here at the bottom is the definition of the class. It had a bunch of fields. One of them is what's the current slide, which is just looking that up from my presentation. And finally, we have this template object with this template tag where I'm defining what the actual element looks like. And I'm saying, well, it's actually going to have this text and it's going to actually show the current slide number. So let's go to the bottom. We have here an instance of this slide number. I'm going to put it in my slide. I've been removing those comments. We now save, refresh, and once we're here, you see this is slide number 25. So once you have one of these elements, you can actually do a lot of other things that also resemble object-oriented or general programming. For example, you can actually pass information to your custom element using attributes. So I can actually put here something like my attribute and say hello Dart. And what I have up here is that we actually already have a field named my attribute. You may have noticed that I have a little difference in the syntax. This is a camel case letter here. This is using dashes. This is that HTML doesn't allow you to have case sensitivity. So in Dart, we say, well, let's translate. Every time you have a dash, we're going to capitalize the next word and associate that with a field in this class that is associated with your custom element. Once we have that, we can actually just put this my attribute in the middle of my template attribute. And now when we refresh, we will see there to say, hey, hello Dart. Cool. So another thing that you get with custom elements is that once you define it once, you can use it in multiple places. You don't have to use it only where you define it. You can actually also import it and use it in other HTML pages. And the way you do that is by using this link rel import syntax. This is another standard out there from the web community. And back to our presentation, let's open another slide here. This is the slide that has that particular text. And I'm just commenting out the link row. And then here at the bottom, we have the other syntax we had to create custom elements, our slide number with our attribute. And we save, we refresh.
Just to clarify, we're importing from our original definition into this slide.
Exactly. So right here, up here, this href is essentially the name of the other slide number. In fact, if I have a typo and I say, oh, I forgot to put this dot here, and I save, you actually see some errors at the bottom. And this is actually, I wanted to highlight this because in Dart, we have a lot of power on making tools available to you that actually give you a lot of feedback. In particular, that editor focuses a lot of the energy on analyzing Dart, but it's also pluggable. And in our case, with WebUI, we managed to also add additional information to understand the HTML itself. So here at the bottom, you see this actual file doesn't exist. That's why you see that red curly line. But actually, interestingly, you also see this second warning saying the slide number is not defined anywhere. I couldn't find a definition because, well, it probably came from that file. But at least you actually get some feedback if you actually had a typo and used the wrong name of your custom element. Right.
So in this case, we were passing a different attribute here as well. Oops.
Yeah.
All right, so I'm sure you guys were really blown away by that slide number example, and now you want to put it in all of your web apps. So the next great step is, fortunately you can, because we have this package management system called Pub. It allows you to share any Dart code, also custom elements that you write, and you can easily put them into work with any project of your own. So in this example here, we have these little tabs here. This is actually a custom element that neither Siggy nor I wrote. It's a third-party developer, Kevin Moore, wrote this.
Who's right there?
He ported a bunch of Bootstrap widgets. And so the way we added this to our presentation is all we had to do is we have this little pub spec. We added our widget library. And then in our HTML in the presentation, we add a link rel just like we did before. And then we instantiate it with his custom element tab name. And it's that's simple. And here's another one that he wrote, the little accordion widget.
Mm-hmm. So we went through a whole bunch of different things today. These are some of the resources that talk about a lot of these standards that are being developed. And if you'd like to read more, feel free to check them out. And everything we've shown you today is available to try it. You can download the Dart SDK and it will work. In fact, there are people already using this. For example, there's the Blossom team. They already actually have been using this, and they even put up also some of their widgets up in another package in Pub.
And the Glyph 3D app as well.
Oh, the Glyph 3D app as well. So there's a lot of things that are continually changing. All the standards are actually still shaping up, and a lot of things are basically moving under our feet. So as we mentioned earlier, there's more things coming, more things changing, and we're just keeping pace. Now, we're going to be here around to answer any questions. We would love for you guys to join us in the Code Lab tomorrow, where we're going to actually hands-on be using a lot of these features. And we're happy to take questions here. Then we're afterwards going to be upstairs in the Dart booth and in the office hours area. Thank you. Any questions? Oh, you're here.
Hi.
Hi, my name is Mark. So you're building a very new language for all the web. Could it be there's a whole, like a bigger picture here for Google, like you want to use this language in many of your products, like for example Google+?
Google is using Dart internally, and we hope that these projects will see the light of day soon.
Yeah.
Okay, so it's great to see some support also from your company then here.
Yeah, there's definitely commitment internally to actually continue using it, and we're starting to see adoption as well, and it's very exciting.
Thank you.
Hi.
Hi, I'm Paul from GDG Warsaw. I wanted to ask, is Dart Chrome extension ready right now? Because since Chrome team introduced Manifest version 2, there is a content security policy, and I wanted to ask, is this ready for applications for Chrome?
So to clarify, you're asking about using Dart as to write your own extension?
Yeah.
Yes. Yes. So that's definitely possible. There's even a mode in which you can actually compile your Dart code into JavaScript and use it in an extension. There's a special flag you need to pass to the Dart.js compiler to say that make it CSP compliant, so that it doesn't use things like eval and stuff like that. But it's definitely possible.
I am wondering about developing, because when you're developing, you use the internal server in Dart editor, and when you develop in an extension, you load this extension as a file, as an app. And
so the only reason we used a server for this is for our web RTC demo, because you can't do that from locally.
Okay, so I don't need to use the server, right?
Right.
Okay. Thanks.
Yeah.
Actually, it's more or less what I was going to ask. But basically, what you showed us today, typically you would have compiled that to a page that'd be served up just like any other static page, and you'd have to use Ajax and whatnot then to get your data back and forth, right?
Yes, I mean, that's definitely, basically the deployment step typically involves something like that, where you're bundling all the Dart code and shipping essentially just one JavaScript file or a couple of JavaScript files that you want to actually put in your app and the resources. Yeah.
And so the way you were using the web components with the data binding, you could do that using standard JavaScript objects that you were pulling via, say, JSON and then bind them into the UI that way?
You can use JSON and things like that. You would, in the current state, you would have to still use Dart in a way to say, okay, given this JSON, how do I process it and create Dart objects out of that? But then your client-server interaction continues to be the same. You can still have JSON over the wire and seamlessly work and support clients that could talk, for example, or be written in JavaScript that would actually use JSON for their rendering, and you can use Dart on the other hand.
Has that JSON to Dart object conversions all been addressed in the client side then?
Yes. There's a Dart::JSON library, basically, that has the JSON parse and stringify APIs.
Thank you.
Hello.
Hey, so I've been playing with Dart a little bit lately, and something's been annoying me about it. I'm pretty sure it's due to my ignorance. I'm hoping you can help me out. The way I've usually used web technologies is I have an existing project, and I just add a little bit of jQuery. Dart, it feels like most of the learning material says, start a new project in the Dart editor, and so there's a lot of magic, and I realize there's command line tools, but if I want to use a web component from Dart in an existing project, I need to compile my Dart to JavaScript, and I need to compile my HTML because there's some transforms. Is there kind of documentation for making Dart play nice with my existing project?
There's some, but there should be more. We, in a brief way, I could say a lot of things are possible, but some of the things, there's still a lot of steps in which we want to take to actually make things like a little bit more minimalistic, like say, you just want this component and that's all what you want. Like those are things that are still not there yet.
I'd say that the focus right now is making like one great experience through the Dart editor.
Sure.
And so yes, we'd love to expand in future time, but our current focus is like one whole ecosystem that works great.
Right. Cool. One great thing where things are moving is the new changes that we're seeing in model-driven views and in custom elements are pushing us to also move a lot more of our logic to be more dynamic and to work more later on, so you don't have to use so much of the tools ahead of time. So I think that's also going to help.
Cool, thank you.
Hi, Simon from Quebec City. Coming from a Git background, one tool that I heavily rely on is Maven to manage my build cycle. I was wondering if there's such a tool that you would recommend for programming Dart for managing hooking into the build lifecycle.
Sorry, what's the tool?
Maven.
Maven.
Okay.
Maven.
Yeah.
I might need some more context. So basically, you have a tool that helps you in the full process of building things and bundling things together and deployment. And
automating testing and deployment and compiling dependency management and everything.
Definitely. That's something that we actually started doing some work on. And we're hoping that, on one hand, that it should be able to also start using tools that already exist. Hopefully that it's nothing Dart specific about a lot of these things, right? But we also have moments where we actually have realized that having a Dart-specific solution actually sometimes helps. And we have a project called Build Tool, for example, that is starting to look into this area. How do you have, for example, a build server in your picture that helps you coordinate all the things between different tasks and steps that you have to do.
Okay, thank you.
And hop. That's true. Kevin highlights there's another project out there that is open that you can try.
In Dart.
Pub. I think so. Pub is actually, I don't know if Pub handles a lot of the package management and installation process. So that's another thing that helps. And they're adding the feature to do deployment as well, so you can take all the packages that initially were distributed and how to minimally put them together so that you know what you have to deploy.
Hey, how does it compare to, or why is it better than Angular?
It's actually, it's a little bit of it's apples and oranges in that you could ask the same question, how do you compare Angular and the standards, right? And I think that Angular has a lot of features that are at a higher level, and they're actually very rich. Things like routing, things like dependency injection, and I think all these things could actually be put on top of what we have as well. And I'm hoping that actually that's the direction when we move forward, so that the standards can be a common ground that you can then pick and choose different frameworks and use them together.
So, yeah, but I guess the key difference really is you're programming Dart versus JavaScript. Hopefully, Dart, the language, makes things nicer, your overall development experience. But we hope to get most of the same functionality.
Hi. Does Dart act as a polyfill when web components or templates are not available natively in the browser? I mean, it does. When compiling to JavaScript, it emulates that function when it's not available.
Sorry,
I couldn't hear.
Web components and templates are part of the W3C standards, right?
Yes, so a lot of these standards, I mean, there's the shadow DOM is there,
Exactly,
custom
but
element.
they're not fully supported by all browsers. At the
They're
moment.
not today.
Does that does something to fill this gap when?
So right now what we're currently doing is filling that gap, and creating an interface that looks the same and works in everywhere. Is a term that commonly people talk about, polyfilling, right?
Exactly.
It's just the same. So we're doing our version of that in Dart so that it has a seamless experience. And ideally, when it's supported in the browser, then it's just simply used directly rather than polyfill.
Okay, perfect. Thanks.
We're out of time, but we will come talk to you guys offline.
But yeah,
come talk to us.
Yeah, come to us. We'll be hanging out here.
Thank you.
And we're going to be upstairs as well in the booth. Thank you.